This is the 9th discovery workshop in our series, and it will be focused on certifiers, ASTM labs, and academic researchers. And so as we go, we would love to see your questions. Please put them in the chat. What we do is we gather those and we work with the panelists to do a response. And so we've got a great panel today, and we will be focused on making sure that they have the time to say and share what they want to say. And so let me share my screen and we can get us going. Welcome, everybody. Great to see you here. As you enter, please feel free to change your Zoom name to reflect your title and your organization. And get started. Okay. So this session is part of a 2-year strategic planning project, improving the circularity of compostables and compost. This is Discovery Workshop number 9, and we are focused on certifiers, ASTM labs, and academic researchers. This initiative involves stakeholders from various industries. Some stakeholders may be considered to be competitors in the marketplace. The future search process shall not be used to obtain an individual company advantage, nor used in pursuit of any anti-competitive objective. By participating in this event and this project and process, you agree to abide by the restrictions set out in this statement. And so what is this project? This is a whole system strategic planning process and project. And these discovery workshops, like any good strategic planning, is exactly that, it's discovery. And so we have set up a series of these to highlight and spotlight the realities, the challenges, the opportunities, and the needs from each of the different stakeholder groups in this system. And so this project is about everybody working together to improve the whole system, and with the ultimate goal of a cohesive and seamless collaboration across all organizations that are part of the U.S. composting system. And so whole system strategic planning is working together toward a common purpose. We have a 3-day strategic planning event in September where we will be creating a common ground agenda and action plans based on the work that everyone is willing to do together. We are guided by an incredible steering committee. We've got 26 organizations across the composting and compostables industries, and we have the opportunity to work together to ensure that we are bringing the whole system together. We have been supported by an incredible group of individuals and organizations, and this group has made this series possible and this project possible, and really appreciate all of their support. And if you are interested in becoming a circularity partner, please let us know. We are here. Hold on one second. As part of a whole system strategic planning change effort. And this is really about engaging everybody in the system, all the pioneers, to come together to create a shared vision and collective roadmap toward optimizing the circular economy of the U.S. composting industry. And so this work centers, but is not limited to food contact compostables. And the strategic planning is guided by the future search model. And so here, this project is focused around circularity, and what do we mean by that? And so for the U.S. composting system, that means that the intentions of compostability are realized for compostable packaging and organic materials, and that the end products produced are able to be put back into meaningful use. Our steering committee has created these intention statements. And so this project is about designing an inclusive whole system circularity model for the health of the composting industry that maximizes environmental benefits, improving collaboration and communication and coordination across all stakeholders, improving information flow between brands, packaging design, point of material sorting, and commercial composting processes for increased value chain effectiveness, and strategies to direct more food waste to commercial composting facilities that creates value, trust, confidence for all stakeholders, and to shift stakeholder behavior to mitigate contamination and the cost of contamination. We have 3 different elements of this project. This is like an hourglass. We begin with everybody in this discovery process, and then we concentrate into a group of 200 for the 3-day structured strategic planning process in September. And then we expand back out to the whole to share out the common ground agenda that was created and the action plans of work streams. And so the real work begins after the strategic plan has been created, and that will include opportunities for each and all of you.
All right. And we are here today with this being part of the Discovery Workshop series. And I'm just going to put the RSVP link. Obviously, everyone here is most likely RSVP'd, but if you have friends and colleagues that might be interested, please share this link with them. We have about 3 or 4 Discovery Workshops left. And please put yourself on mute if you're not on mute. Okay. The purpose of these is to gather data to be used as input in the strategic planning process and in the event in September. So we've recently sent out an email blast, I think it was on July 3rd, and it has all of the data, the themed insights from the first 7 workshops, I believe. And so if you dig for that email, or if you haven't received it, reach out. There's a link to a Google file. You can really see the themes across the board of what's coming up from the different players and stakeholders in the system. And that's going to be used as fodder for the conversation. So these are every Thursday. I think we're working on adding maybe a 14th workshop as well. So more to come on that. And yeah, without further ado, we're going to move into the panel portion. So as Candy mentioned, this is for certifiers, ASTM labs, and academic researchers. We have Rhodes Yepsen, Executive Director for Biodegradable Products Institute, Janet Thoman, Compliance Director, Compost Manufacturing Alliance, Mike Galloway, Lab Director, Control Labs, Paul Fowler, Executive Director of Wisconsin Institute for Sustainable Technology at University of Wisconsin Stevens Point. So he will be reading in by proxy today. We have Kevin Okamoto, President of Green Bottom Line, Inc., and Fred Michel, Professor of Food, Agricultural, and Biological Engineering at Ohio State University. So wonderful lineup of folks to offer a well-rounded perspective. We have 5 questions. And so we're going to be taking about 3 minutes per panelist per question. And we will go in the order listed above. If you have any questions, please put them in the chat. We will try to get to them during the panel itself. If we do not have time to get to it during the panel itself, we will reach out and answer those and send them out as a follow-up.
And so next up in 2 weeks, we have our 10th. And so that's on August 1st, and it is focused on professional associations within the industry. All right.
All right, so our first question, I'm just going to read it. It is, where does your organization fit in the world of composting and compostables? Why does it matter? And what role do you play in the testing, lab, and certification process? So let's start with Rhodes.
Great. Thank you for having me. Rhodes Yepsen, Executive Director of BPI. BPI is a science-driven member-based association that supports a shift to the circular economy by promoting the production, use, and appropriate end of life for compostable and biodegradable materials. This includes work on claims with our certification program in conjunction with work on standards, public policy, and education. Our approach to certification is system-based, meaning we don't simply advocate for a one-to-one replacement of items with compostables. Instead, we focus on careful certification criteria that evolve based on input from across the value chain, like only certifying items associated with food. Our members include raw material producers, packaging converters, distributors, restaurants and venues, municipalities, haulers, and composters, with monthly committee calls, webinars, and an annual summit where people can provide input on this certification criteria. The certification program was BPI's first initiative and continues to be the one we're most recognized for. Our role in certification is to orchestrate that program, working on standards at ASTM and ISO that are the baseline of that certification, setting the rules in a certification scheme that is published on our website, partnering with external laboratories and a technical contractor to perform conformity assessment. Ultimately, what BPI's role is focused on sort of what I would say the beginning part of the process, helping companies go through that process with an application, providing customer assistance along the way to answer questions, since it can be quite complicated, especially for companies who are new to the certification process. And then at the end of the process, issuing a license agreement, identifying and approving artwork, seeing how claims are being made, publishing a list of individual products in our database, so that, again, from a transparent perspective, organizations and consumers can identify whether a specific item, down to the size and print of that cup that they are looking at is covered by the certification or not. I think because we are an association, a lot of our other activities support that certification work, and there tends to be a fair amount of interplay between the certification itself and that work on policy, education, and communications, which I can get into later.
Great, thank you. Let's go over to Janet.
Hi, thanks. Unmute myself. Janet Toman, I'm the Compliance Director for the Compost Manufacturing Alliance. CMA performs field disintegration testing and certification of compostable products. And we come at it from the composter's perspective, since it's a program that was born out of a composter's attempt to problem solve for their facility. So we certify products to both laboratory standards, the ASTM standards, as well as the field disintegration piece. Basically, that means we take products, and after we have, or while we are vetting the laboratory standards, we put them in commercial compost facilities during a normal active process and determine the degree of disintegration through that active process, so that we have a sense and can provide information to the composter about how that is going to work in their particular system. We perform our own review of the laboratory standards. We are third party to our customers who are applying for certification. So ASTM standards, the specified testing is performed at independent laboratories, some of which are on the call today. And then we take that information, review it, make sure that that the product complies with those standards. And then we marry those two pieces together, the lab standards and the field testing, in order to come up with a certification. In addition to that, as part of our work, we do a lot of research. There's a lot of interesting questions in this area, and there's a lot of unanswered questions. And we have the great good fortune of having access to commercial facilities where we can ask a question about, facility parameters, or about product makeup and the interplay of those two. And we can go out on a practical level and test and see what happens. If we tweak this parameter, is that going to have an effect on product performance or on quality of the end product? So, and why does it matter? We need to have clean compost, and we need to be able to find ways to make, as I've heard before, make the promise of compostables a reality. Compostables bring in organic materials. We need to get that material out of the landfill. And the better we can make this system work, the more we're going to achieve that goal of mitigating greenhouse gases and achieving the end goal that we all want, which is to address climate change in a positive way.
Great.
That's it.
Thank you, Janet. Mike.
Yeah, hi. So we're Soil Control Lab, or Control Laboratories, but better known as Soil Control Lab. We started 1954, 1955, something like that, as a soil lab, an agricultural lab. We expanded into drinking water and wastewater testing. And then fortunately for us, there's a lot of composting in our area. So we started doing testing for local composters, and it slowly expanded, and we were doing more and more of that. But in the 90s, the U.S. Composting Council started, and we helped with the process of making their TMEC manual of methods, and which is the basis of their testing program. So we formed a lot of strong relationships with composters across the country. So the BPI, their original partner in their program was the U.S. Composting Council, and we got approached by BPI to do this testing for compostable products. And it actually, turned out to be a very good thing. I think our role, because we have those relationships with composters, and we have some insight into, the perspective coming from composters, which I feel was an overlooked detail. Like the products were made, they figured composters would be excited about them automatically, which it's really more about eliminating contamination from the feedstock stream, really. But so I think that's really, a lot of the purpose of this panel, I think, is bringing all the different perspectives together, and that's one of the roles that we play due to our position in the testing industry. So, oh, and then the role that we actually do participate in ASTM, helping develop the standards for testing, and then we do the testing for the CMA and BPI programs, the lab portion of it. So, so that's our role.
Great. Thank you, Mike. Okay, I'm going to read Paul Fowler's responses by proxy. So he says, for over 25 years, we have done applied research and development in the creation of functional materials from natural resources, including biocomposites, bio-based thermoplastic, and thermoset resins, plastics, paper, films, and additives. Innovation was supported at our lab in Europe by the EU as successive framework programs allocated funding to cross-disciplinary multinational consortia to research and develop, for example, lightweight or biodegradable or compostable multi-layer films designed to divert material from landfill and have a reduced environmental impact. Sustainable packaging and waste management entered mainstream conversations, and some of that focus was on design for end of life that ultimately led us to study biodegradation of bio-based films as well as fibers under composting conditions, both in labs in the UK and in the United States. This matters as we strive to divert valuable resources away from landfill and towards less impactful management options, and for alternative handlers and processors, whether it is composters or recyclers, to have confidence that those materials are candidates for alternative end-of-life management. They require some evidence that effect. Compostability testing under modeled industrial conditions provides a part of that evidence base. And now we will shift over to Kevin.
Ariel, can you tell us who that is? We don't know who that is.
Paul Fowler, the executive director at University of Wisconsin, Stevens Point. Yes.
So he's an academic researcher.
Yes, but he's also involved in testing, I believe.
Yes, Wisconsin Stevens Point has an accredited testing laboratory.
Thank you for that clarification. Thank you for the question.
Yeah, thanks, Heather, for the question. And then for all future questions, if you can bring those into the chat, we're both watching that, and we will make sure to bring that to the forefront.
All right, Kelvin, to you.
Okay, so I'm Kelvin Okamoto. My consulting company is Green Bottom Line, and we focus on sustainable materials and packaging development, commercialization, testing, and certification. However, I'm here more as the chair for the ASTM D2096 subcommittee on environmentally degradable plastics and bio-based products. I can't speak for ASTM, no one's really allowed to, but I could talk about what ASTM is and where it fits in the total system for setting standards and test methods and specification standards for industrial compostability, other types of biodegradability, and so on. Similar to what ISO and SEN do also. So I'm here more to talk about how ASTM standards, test methods, and specifications are. And just as a clarification, I'd like to say that test methods are specifically that they're test methods that cannot be passed or failed. And specifications are more like the defining standards for what it means to be, say, industrial compostable or water biodegradable or so on. And you'll see a lot of incorrect claims to ASTM standards, most times to test methods where they say they pass. And it's just be noted, you cannot pass or fail a test method. Thank you.
Kelvin. All right, and then we'll go over to Fred.
I'm Fred Michelle. I work at Ohio State University, and our role really is to conduct research and educate graduate students. Facilities here, both a full-scale composting facility and
Hey, Fred. Fred, I'm just gonna pause you for a second. You're a little bit broken up. I might suggest calling in.
Okay. Let me do that.
Candy, should we come back to Fred? What do you
Yeah,
think?
I haven't seen the phone number come through, and so
Okay, we'll come back to you, Fred, when you have a phone line. Do not worry, do not fear. We'll get back to we'll go back to the first question. But I'm going to shift us just to keep us moving from a time standpoint. Candy, do you want to read the second question?
yep, absolutely. And so Fred will watch for your phone to come in, and then we'll shift back to you when we see that. So question 2, we've got 2 different versions. We have one for the certifiers and we have one for the testing labs and the researchers. And so for question 2 for the certifiers, the question is, what are the differences between certifiers? What does it mean when something is certified, and what is involved in the certification process? And then when we shift over to our testing labs, the question is, describe what is involved in the testing process. What are the variables and tests that need to be known in advance? For example, scale, specifications, standards, certifier, et cetera. And so we're going to start with Rhodes.
Yeah, I would say that certification means something that has been assessed for conformity to a requirement. This may or may not include an independent standard or independent testing. So in many ways, certification and certifiers take all different shapes and sizes. Some set their own standards, conduct their own tests, create certification schemes, do conformity assessment, and issue the certification mark. So the entire value chain can be held within the brackets of a certifier, quote unquote. BPI, again, as a member-based association, does not play most of these roles. We are really acting as that orchestrator of that entire system. And then we've selected a couple parts of that value chain to retain control over. So we developed the certification scheme and licensed the use of the certification mark. Why we've focused on those aspects really has to do with creating a framework for that claim that allows us to consult with diverse stakeholders and make sometimes bold changes to the requirements using influence within the ASTM or ISO standards or within the certification scheme ourself or the licensing requirements around the use of the mark. We also find that it has been, very important for us to try to retain some independence from specific aspects of that certification value chain. So a core part of BPI's origin that Mike alluded to is, a bylaws and framework to say that we would not develop our own standards. We would only rely on independent consensus-based groups like ASTM and ISO. We would not do the core testing ourselves. We would work with independent laboratories that have been, accredited or audited for appropriate ISO criteria. And that we would not do the conformity assessment ourselves either. We used InsertGo today as our conformity assessment provider. In the past, we used an independent network of academics and universities. Once it comes to those criteria around licensing, as Mike said, that program was launched as a joint initiative with the U.S. Composting Council. It actually had both logos on the certification mark. The license agreement was signed for both of the organizations. The funding, there was a shared funding model, and the premise was, pretty great, right? The items designed to this standard for compostability, which was developed based on field testing and literature for best practices for composting, will work in facilities that meet the composting handbook and operating guide. So yeah, I think that the last thing I'd say around that is that, within this role of certifier, one of the things that can be really challenging when you look at those different sections and try to think about, like, when do they need to be separate? When is it okay for a certifier to merge several of those roles? Is, again, thinking about how you build consensus and trust along the value chain, and who and where those changes are made. So I think that's just something that's sort of food for thought for this discussion today is, where are those requirements and standards important, and how do we make sure that people understand the different roles played in certification?
That's great. Thank you so much. All right, Janet.
Okay, thank you. I think differences between certifiers, I think there's more commonality than differences. I think we're all trying to achieve the same end, which is to make sure that the products entering this stream are safe and have the potential to facilitate organics collection, and ultimately not to pose problems for the receiving facilities. I think there are certainly differences in some of the mechanics of how these certifications are performed, and some of the very small details that are we may have a different view on, but ultimately, I think we're all trying to achieve the same end, and using the fundamental structure of here is a standard in order to achieve certification. The product must check all the boxes for those standards. So CMA does add the field testing piece in addition to requiring passing laboratory testing to the ASTM standards. And so certification just means that an outside body, not the product maker itself, has reviewed certain characteristics of that product and confirmed that product meets these particular standards. And I always, when I talk about what I do, it's important. Certification is important because if you see something on a shelf and it says compostable, how do you know, right? You can use words out in the market, less so now, fortunately, but there needs to be some external review that confirms that the claim that you are making is accurate and can be proven. For us, the certification process involves providing documentation on every item, providing the laboratory analysis, and providing the products so that we can then take them and perform the field disintegration testing to assess whether or not the disintegration within that particular process is sufficient. So
That's great. Thank you. We're going to shift over to the labs with Mike.
All right. Well, this one's actually an answer that could take half an hour or longer to really cover. So I'll just touch on the basis. So one of the things that we get asked routinely is, can I have a quote for testing? But the client oftentimes will give no details. Well, see, that's actually, you can't do it. You actually need to know the details of the product to be able to determine what the path through testing is going to be. I don't know if I really have time to cover that in full, but let me touch on the different parts of the testing that are actually done. So there's three parts of three general parts. There's disintegration testing, which is 12 weeks of composting. It's really meant to assess whether the product's going to visually disappear and whether it'll represent contamination at the end of the composting process, because everybody wants to have compost that doesn't have visual contamination. The second part is ecotoxicity or phytotoxicity testing. So it's basically to prove that once we compost the product, that the compost that's produced won't have any toxic effects to plants. And then probably the more complicated portion of the testing is biodegradation testing. So that's actually, or it can be called mineralization testing, and it's the process of the polymers breaking down, and as a byproduct, carbon dioxide being produced. So that part, actually, most of the testing is designed around the entire product being tested. Well, the biodegradation is actually ingredient by ingredient. And lots of times people get by without needing to prove the biodegradation themselves because they're using the data that's already been provided by the polymer producer, additive producer, that sort of thing. And so that's why trying to determine the path through testing can be complicated, because if you have a lot of certified ingredients, well, then you actually don't have to necessarily reprove the testing on those components. And then there's also the complication if you actually took 3 certified compostable films and combine them into forming a potato chip bag, for example. Well, you still need to actually do testing, even though the 3 portions are all individually certified, because when you fuse the 3 materials together, you may in fact not have a compostable material, just because of the fact that disintegration may take too long. So anyway, I think I'm probably getting a little close to that time limit there, so I'll leave it at that. But this is a long topic to cover.
Yeah, absolutely. And just appreciate everything that you're sharing kind of within this format. And so I know that there's probably a lot more to say. So thank you. I am going to read out Paul Fowler's response. And so again, Paul Fowler is with the Wisconsin Institute for Sustainable Technology. That's part of the University of Wisconsin at Stevens Point. And so he says, for us, before we even start the testing process, we want to have a good understanding of the client's intended end-use application, as well as a comprehensive inventory of the chemical and/or polymer components of the test item. Not all clients are prepared to give us this information, and we believe we can add value to the process by pointing out any potential red flags in any list of materials that would likely cause a product not to meet a particular threshold value upon testing. We want to know about any current certification of any of the components used in the construction of each item. We want to know if the client is intending to seek certification with a certifying body, and if they have had any discussions with that body. We often advise a potential client to start that conversation sooner rather than later, particularly if it is unclear whether the end use application of the item falls within the scope of the certifying body. All of this background provides us a basis to identify the standard specification, ASTM D6400, ASTM D6868, ASTM D8410, that best applies to the particular test item and to identify the specific tests required and thresholds to be met in the testing process. As for what is needed, as for what is involved in the testing process, the various test methods, ISO 2200, ISO 16929, ASTM D5338, and OECD D08 guidelines set out the general procedures to be followed, the conditions to be used, and the data to be recorded and reported. And so we want to hear from Kelvin next.
Yes, so as ASTM is a standard setting organization like ISO and like CEN. The difference is that ASTM is a consensus organization. In other words, anybody can be a member to join and participate in the discussions. And so you have producers, you have testing labs, certification agencies, and as well as the public and users all involved in helping to set the standards. Producers are allowed to have no more than 50% of the vote. Therefore, they don't swamp the, whether a standard passes or does not pass. It should be noted that standards organizations like ASTM are independent of the testing labs and the certifiers. And that's intentional because the testing labs, that is the certifiers especially, can set additional standards or requirements for passing industrial compostability. And a perfect example of that right now versus ASTM standards is the fact that you must be less than 100 parts per million total organic fluorine. With the whole issues about PFAS, those are being worked on to be written into the ASTM standard. It is an ISO 17088. And the other part is that then the test methods are what the testing labs must follow, but they may have additional tests, or the other thing is that some of the tests may have some variations that each of the testing labs have figured out that they can do. With the variations in the test that may be run, all the labs hopefully are generating similar results though. The standards do have to be updated every 8 years at the longest. If it's not updated or revised or reapproved in 8 years, the standard actually goes withdrawn. So the standards are constantly being revised, reviewed, and because of that, we're trying to keep them up to date with the latest information. ASTM D6400 is a almost 30-year-old standard at this point in time. It has been revised several times since then, and we are still looking to continue to revise as more information is found. I mean, back in the mid-90s, we weren't as savvy about what was needed to be industrial compostable. And we're probably not going to be as savvy now as we will be in another 30 years. So we want to make sure that we are constantly updating those things and everybody can be involved.
That's great. Thank you so much, Kelvin. All right. Paul, I see you're back on. Thank you so much. I am going to put 6 minutes on the clock so you have a chance to answer both question 1 and question 2.
Oh, you mean me, Fred? Or
Fred, yes, sorry. Yes, Fred.
Okay.
Sorry.
Yeah, okay, great. So I'm Fred Michel. I'm a professor at The Ohio State University here, and I'm on the Worcester campus. And my role really is we do research into many different aspects of composting. I've done that for 25 or 30 years. So everything from process development, looking at various different contaminants, including things like persistent herbicides, pathogens that may be present, and then also sometimes looking at biodegradable materials, which may include bioplastics or natural materials used for various applications. So the facilities we have here include reactor systems that enable us to do some of the ASTM standard methods. For example, we have 15 different individual reactors that can hold about 1 kilogram of material wet, and we can measure the CO2 and oxygen consumption by all of those reactors continuously with a data logger over a period of 50 or 60 days or even 90 days, depending on the length of the experiment, and use that to measure mineralization, as Mike was describing it. So we're looking at the amount of CO2 produced by a control, which would be just finished compost sitting in the reactor, versus a reactor with the same amount of that control material plus some added biodegradable plastic or a positive or negative control in that situation. So in those experiments, we'll usually do those in triplicate or quadruplicate for each test. So it takes a lot of reactors to do that. And then we're also using positive controls, which may include kraft paper, sometimes white paper, sometimes we'll use starch to make, and then we look at the percentage of the CO2 evolution from those positive controls. And usually we stop the test when we get something like 80 or 90% mineralization from those positive controls. And we'll compare that to the introduced samples. On occasion, sometimes people want to go for 100 or 120 days or even longer, and we can do that. So we also have a full-scale composting system here where we have windrows that are continuously in operation, where we can potentially introduce materials. We haven't done that so much. And we also have a system of home composters, which we recently did some work on, just looking at disintegration of materials in that system. In addition to that, we have 200-liter systems, which are also fully instrumented. We have 4 of those, and those are adiabatic, meaning they retain all of the heat that's produced. So we can look at how do materials heat up and for what duration. It's more closer to the heating process that goes on in a real windrow versus in the reactors where we're controlling the temperature from outside and introducing a temperature, usually 55 or 60 degrees C. So the question about, okay, so what the role I play in certification really is we work with companies who are interested in doing research on their materials. So they'll come to us and say, we have this material, we'd like to test it. So we aren't a certifying laboratory that's been certified to do ASTM tests like this or to meet some of the standards that BPI may have. We're not a certifying laboratory, we're more of a research laboratory, but we can follow the ASTM protocols in our research. And then the second question was, what do you mean when something is certified? Okay, so yeah, I think I answered kind of the second question as well.
Okay. And if you think of anything else, let us know. But thank you. And thanks for flexing and adapting and joining by phone. I know sometimes sound can be tricky.
Sure. Sorry about the problem there.
No issue. All right, let's shift to question 3.
So question 3 is, what do you believe are the greatest opportunities created by researching, testing, and certifying compostable materials for your customers? Let's start up at the top with Rhodes.
Yeah, first of all, we serve a lot of different audiences or customers. So yeah, we typically talk about them as an audience rather than a customer. But our certification customer, to use that term, what they really want is a clear criteria for designing, testing, and marketing an item as compostable that can be trusted and agreed to along the value chain. When that trust starts to erode, customers and audiences lose interest in compostability. What this really means in terms of research and opportunities is are things that can build confidence that compostable products are a feedstock that can be safely composted in facilities that are designed and operated to take those feedstocks, just like different feedstocks, yard trimmings, food, and biosolids may have different design considerations. To this effect, we think that for research, one of the biggest things needed is a standardized field test method. BPI has been leading a collaborative monthly ASTM working group call over the last 2.5 years to develop such a standardized field test. Having agreement on a public method that's rigorous, that can be updated through consensus at a group like ASTM, we think will go a long way. They'll tell us a lot about, standardized field tests will tell us a lot about a facility's capabilities for processing compostables and about compostable products breakdown in general, as we saw with the composting consortium tests last year, which beta tested this draft ASTM method that we're working on. It may not have enough precision or reliability to determine if an individual item is compostable, though. Even with defined operating conditions in our tests, which there are a lot of them, the big variable being assessed are those conditions. The compostable products have a lot more consistency and constancy because they will be required to have already been assessed for ASTM specifications for compostability, meaning that they have some common denominator. So I think that, yeah, that ASTM field test method is probably the biggest area of research that we see.
Great, thank you. Janet.
Okay, so greatest opportunities in this area, certification. I think the opportunity there is, as Rhodes mentioned, is to foster trust in the products and in the system. Testing and research, I think, is such a huge area of opportunity. We don't know what we don't know. As Calvin mentioned, you know, what we knew 30 years ago is very different than what we know now. And that should continue to evolve over time. If we can do research, we can do testing, we can raise all ships. It's good for everybody in the value chain. There's a lot of creative tension in this space. We have a lot of stakeholders, and everybody is seeing the system from their own perspective, which is one of the reasons that I'm loving this future search process, the discovery workshop process, because I think we don't get enough opportunities to understand other perspectives. And it's not bad that everybody has their own perspective, right? It's absolutely necessary. And if everyone is fully engaged in problem solving, creative tension is not necessarily pleasant, but I think it's vitally important. And I think every piece of the puzzle needs to be functioning from their own perspective in order to get anywhere new. I mean, the definition of insanity is doing the same thing over and over and expecting a different result. And so I think research is a great way to not continue to do the same things over and over again. We can learn a lot. We can make adjustments in our course and move this whole space forward. So yeah, absolutely, there needs to be a lot of research on the product end, on the composting end. Yes, a field testing standard is super important and has been in progress for some time. That is another area where, you know, there's creative tension and not everybody is going to agree. But in the end, one of the great things about an organization like ASTM is that is a place where we can all have our opinions and ultimately come to consensus. So this is one of the areas that makes me most excited, is the idea of research and getting everyone pointed in the same direction, even if we're coming at it from a different perspective.
Thank you, Janet. Mike.
All right, I didn't know how to interpret this question, to be honest, but so I think I'm just gonna go with, actually, I feel like the greatest opportunity is not missing an opportunity, which in this case is not for us. It's really for industry as a whole. Is that there have been a lot of false claims, and I feel like, you know, if there are false claims of compostability or biodegradability, well, then the composters and the consumers both stop listening. So it's really important for everybody to really understand the framework, put in the required testing and the required effort to understand the process, what goes in, because some people just want a compostable product, but they don't necessarily put the time in to research what goes into really properly making a product. And really, you know, part of that's also understanding the rules. So there's an education component to this, where really, I guess the manufacturers, it's you know, there's a lot for them to know. So, and then sometimes what happens is that there'll be there'll be additives to the process, or, you know, maybe it's yeah, well, an additive to a product, so it maybe represents something that can be used in under 1% of the composition of the product, and the producer of that material will actually tell a new client that, oh, well, we're compostable. Well, just because they have a client that was able to obtain certification, but the way that client obtained it was they didn't have to test biodegradability on that 1% component. And so now another manufacturer is using it a higher percentage, and they're going to be forced to actually test for biodegradation. And this is a too common of a case where then the additive miserably fails. And so anyway, so sometimes the opportunity is not blowing your first opportunity. And then the other opportunity here is continued research is a really important aspect. You know, everybody should be striving to always improve in this field. One of the things that I think people think of things as being a pass or a fail, and if they pass, that's good enough. Well, hey, you know, there's a spectrum here, and something that passes the testing, hey, maybe it breaks down just barely fast enough to meet the criteria. You're going to be better off if you can break down quicker, because this is actually one of the reasons why the CMA is so important. That just because you can pass the lab testing doesn't necessarily mean you'll pass in all the different composting processes, because there is variability there. So I guess that's my answer to that.
Great, thank you, Mike. Okay, I'm going to share Paul's answers. So he says, we are able to help some clients to fail fast and so quickly move on in the development of their innovation pipeline. This is particularly the case for those clients that are, for example, developing new coatings or laminates to improve the performance in use of their intended substrates. This valuable information can obviously be gathered from the performance of the tests themselves, but even before, by applying our knowledge of polymer and chemical systems to the structures and compositions of the items being tested. Of course, a successful testing outcome also affords a client a point of differentiation for their product in the marketplace. So that was Paul, and now over to Kelvin.
So I'll make it a pretty brief answer. In essence, the opportunities are is to make sure, as Rhodes and Janet and others have stated, is to make sure that the compost that is generated once we put in compostable materials does not include any materials that we would not want in there. That goes for PFAS or microplastics or other things like that. And there's a lot of research that still needs to go on around some of these items. PFAS, probably not much more. We sort of know where we need to go there. But in terms of microplastics, one of the big questions is what happens to all the paper coatings that are thermoset plastics? I don't think we really know what the answer to that is. Most of them are probably not compostable. That's why, you know, various companies are working on making certifiable compostable coatings. Adhesives are also another potential issue because those technically are also thermosets. So that's where our opportunities are, is to do research on finding out what happens to various materials that in the past no one really ever thought about.
Great. Thanks, Calvin. Fred.
Yeah, so the question about what are the opportunities? I think the opportunities for the research are really to develop understandings of the conditions under which some of these different materials that are being developed actually do or do not biodegrade. You know, whether there's some examples of some materials that may biodegrade at higher temperatures and much less so at lower temperatures, and that may not be captured in the certification testing, but could inform us on how to perhaps attempt to compost these materials. Understanding how different materials, whole materials made from multiple other materials, mineralize or don't mineralize, as Mike sort of described. We have a mixture of materials. Assuring, another thing that mineralization testing can do, which sort of the other type of testing can't really do, is to assure us that these materials aren't resulting in microplastics as they disintegrate, if we have a positive disintegration test. So mineralization can give you that information that's important, I think, with the whole materials. And I guess the last one I'll just mention is from a university standpoint. Our opportunity is to publish peer-reviewed scientific information about these tests, which is available to the public to review. Which is much more difficult to obtain from industry or from laboratories who may have to keep that information private. So we're able to do that. We're able to buy materials off the market, test them, and publish the results of those tests. Sometimes that leads to issues, but I think that's an opportunity that we have because the public wants to know what these test materials do in these situations. I think as much as they do whether or not it meets a defined certification. It's out there. Some may want more details about that.
Well, yeah, how great to just add another layer of accountability is kind of that third party just check and balance system of looking at what are the products on the shelves and what is in them and do they meet the standards. So that's great. Well, we have our next question. Let me just get our time on the clock. And so our next question is this for you. Is what have been some of the greatest challenges your organization has dealt with when it comes to researching, testing, or certifying compostable materials for your customers? And so we're going to start with Rhodes.
I'd say one of the greatest challenges is showing the broader world that the difficulties in real world processing aren't necessarily a failure of compostability standards or because they're lab-based. First, most of the issues that we see with processing aren't with the compostable products themselves, it's with contaminants. And that means that there's limited ability for the compostable products themselves to solve the problem beyond labeling, supporting education, getting involved with partners that work on conventional packaging to address misleading terms and labeling either voluntarily or through public policy. Second, one of the challenges related to that understanding is, as we've discussed a lot, the variability in compost operating conditions, where there's no set of conditions or time frame that is standard for processing. I know this was a question in the chat. This means there is no benchmark to use for updating the ASTM D6400 standards timeframe. If the timeframes and conditions range based on compost technology, feedstocks accepted, ambient conditions, markets for finished compost, things like that. This makes it really challenging when the broader public has claims that compostable products don't actually compost in the real world. We would say, yes, they do, just maybe not in your specific system if it's not designed or operated to process these materials, just like there are different conditions needed for different feedstocks and for different finished compost markets. So that's what we see as probably the biggest challenge related to research, testing, and certification.
That's great. Thank you. All right, Janet.
Yeah, to some extent, I would echo what Rhodes says in terms of it's a very complicated area. There are, the nature of composting is very dynamic, and that's the reality of the situation. There are, in terms of certifying, there are very small details that it's always something new every day, and not just on the field piece, but in evaluating the laboratory analysis. And field testing is really hard because it's a dynamic process. It is, and it's a manufacturing process, and things happen at facilities, and weather happens, and it's not, it's not a process where you show up at a desk, you look at something and then you say yes or no. Field testing is not easy. So more broadly, I think one of the greatest challenges is back to sort of that creative tension. It's if all the pieces are not at least moving in the same direction, it's no longer creative, it's just tension. And I think that that thwarts everybody's ability to do the work that they need to do, and for the entire system to get to the next level. Yeah, it's a very complicated, it's far more complicated than folks who are not in the certification or testing space realize. And I think conversations around what the details of all of this entails are super important to inform, to inform the entire system, to inform product manufacturers, to inform composters, to inform laboratories, to inform field testers of, what is the next right step for us.
That's great. Mike.
All right, well, this one was a difficult one to know what direction to take it, but I think I'll go the route of, actually, I think this ties into what both Rhodes and Janet were talking about, where education is a really challenging thing about this, on the consumer side, but really where I'm thinking is, educating the manufacturers about the requirements and all, but also when you're trying to develop the standards that are going to try to, estimate what's going to happen in the real world, well, there's a lot of complexity involved, and there's a lot of, well, the rules are already very, complicated to the average person. So trying to explain when we actually start a relationship with a new client, there's a lot of education, a lot of effort on my part to try to explain the rules to the client. Lots of times now they're starting to know, but 20 years ago, that wasn't wasn't the case. People didn't know the rules. But now when we're trying to develop the standards, it's how complex do you want things to get? If you try to, there was discussion in ASTM on having different disintegration methodology, and we were trying to decide, do we want to cover different time periods and that sort of thing. Well, the rules get really complicated quickly, and that's where I mentioned earlier, well, the CMA plays a role in that. If you actually want to see, does the product break down in a short time period in closed vessel composting setup. Well, test it with them. But so that's really been the challenge, though, is the complexity, trying to get the testing to reflect the real world. But the real world, there's lots of different variables involved. So that's the challenge, and it's going to be the continued challenge, and keeping the rules simple enough. And the testing, you don't want the testing to be too complicated where no one can afford it. That's the other side of things. So
That's great. Thank you. I'm going to read from Paul, or sorry, I'm going to read, from Paul Fowler. And so what he shares is there are several. Some involve challenging clients, and some are challenges around the lab and test methods. I'll start with the clients. Clients who are being driven solely to undertake testing so they can substantiate a marketing claim. Sometimes that claim may already be on a package and available for sale. They want the answer yesterday and do not want to hear any bad news. Clients who believe that their items should pass testing because they are just natural materials and believe that the lab has made a mistake. As for the lab, we are running long-term tests, and challenges can arise with scheduling, having capacity and space, as well as managing the ebb and flow of testing requests. Finding and retaining excellent lab staff is key, and training new staff takes time. We are forever in a cycle of continuous improvement. Test methods and standards change with time, generally for the betterment of the testing process, but this can lead to challenges in terms of setup of the apparatus and equipment. And the last challenge is that the testing relies on the use of natural systems, microbes, fungi, seeds. There's inherent variability in nature, and we are challenged to minimize or harmonize that nature variability always in our testing. And so next to Kelvin.
Thank you. And I agree with everything that everyone else has stated to date regarding this question. And I'll just add a couple more. One is challenge is the mislabeling, misclaiming of compostability, which then makes a lot of people then say things do not compost, and they then think it's just nothing does. And then just going back to, the question about that was raised about ASTM standards. It's same for ISO, it's same for CEN. Standards for testing that may not be to the real world. Lab testing meets very specific conditions, and therefore you will get set results. Unfortunately, as Janet and Mike and Rhodes and others have said, industrial composting is done by lots of different ways. And there are at least 3 major types that use different temperature ranges, different time frames, etc., from anywhere from 24 days to 180 days for active curing, for active composting. Plus, then you have curing. You also then have anywhere from 138 degrees Fahrenheit to 170 plus degrees Fahrenheit. They all affect how it works in the field. We did go back and do a study in 2012, 2013 in the lab, looking at changing those conditions in the lab. In the lab, there were no differences in the results, no matter whether we shortened or lengthened the results of the test. Once again, demonstrating that there's a big difference between what happens on a small scale versus what happens on an industrial commercial scale. So that's the importance of making sure that we go back and actually tie things back to what actually happens in the field. And it may, unfortunately, be composter dependent. Every composter, unless different ones run similar conditions. That is definitely a challenge. And testing takes a long time, and we know that. Unfortunately, you cannot accelerate the test, because if you raise your temperatures, you then to speed the test up, you go into a different microbiome, and therefore your results could be different.
That's great. Anything else?
That's it, sorry.
Okay, no, that's okay. All right. And Fred.
Yeah, so I'll agree with most of what's been said already. Just to add a few more things. One problem we often run into is having enough material to test when you're developing novel materials. I'll tell them, we need 200 grams or something like that or more, half a kilogram, and they can only generate, 20 or 50 grams. So we're always struggling to get sufficient materials to do all the characterization we need when they're these novel materials. That may not be a problem once these are in the market and are being produced at large scale. Then the other thing is maintaining equipment and as we heard from Paul, you have a project which may go for a few months, and then it ends, and another project starts after a few months later. So you're always maintaining their equipment, getting that set up, and having funding for a student to be able to learn the methods, do some experiments, and then write up some reports and papers based on those experiments, which is more like a 2, 3, 4 year process versus a 6-month process of testing a material. So that continuity is difficult. So those are two other things I'd mention.
That's great. Thank you so much.
Okay, we have one more question left. It is, what should other stakeholders in the supply chain, the solid waste management system, and regulators take into consideration when problem solving around these issues? What would be most helpful? Rhodes.
Yeah, this is a really good one. I think what I would say is looking back at some of the work that we've done to date and identifying what has worked well and where has it fallen short. Back in 2021, BPI and Biocycle convened a stakeholder workshop series that included a cross-section of the industry with 2 primary goals: identify and confirm the top barriers to the acceptance and successful processing of compostable products, and build consensus on a single set of acceptability criteria so that compostable products can be accepted and processed by a broader set of composters processing food scraps. A little bit of a mouthful. What this resulted in was a detailed roadmap that led to some great collaboration over the past few years, like stakeholder work to develop shared positions between BPI and the US Composting Council on product labeling for compostables, extended producer responsibility to get funds to composters, et cetera. Still, more work is needed to identify, again, what went well with those initiatives and where have they fallen short. What's most helpful and necessary, in our opinion, is to go back to that core nugget of building consensus on a single step of acceptability criteria, a common denominator, rather than multiple criteria based on changing compost technologies and timeframes. We need this single set of acceptability criteria, and we need stakeholders to know this, because otherwise materials and products cannot be designed, manufactured, and tested in a way that the claim of compostability will be trusted so that these items can be collected and processed in compost systems. And this isn't just about packaging. I'd say, we haven't really touched on this today, but this is just as much about food scraps diversion, which are the #1 material going to landfills, where they create the potent greenhouse gas methane. We need to divert those organics from landfills, use that compost to regenerate our soil. The sooner that we can align on compostability criteria, the sooner that we can transition to the circular economy and focus on topics like compost infrastructure funding, because we need a lot of that funding.
All right, Janet.
Okay. I think in the end, what's really important to keep in mind is, to begin at the end. There's obviously a lot of challenges in this space, but at the end of the day, if we cannot solve the multitude of problems that we have in compostables and organics diversion, at the end of the day, it's the compost facility operators who are going to make the final decision. And unfortunately that, if we can't solve these problems, that decision may be, I'm just not going to take it anymore. And I think that is one of the overriding factors that anyone creating policy or any stakeholder keep in mind. I think to me that is very motivating to engage in problem solving in a very collaborative and open way. I think that coming to the table with that in mind needs to be primary. And other things for stakeholders to keep in mind is that it's not simple. None of this is simple. The more layers you pull back, the more complicated it becomes. And I see a lot of policy. I see a lot of things happening in terms of based on assumptions, and sometimes those assumptions are absolutely wrong. Sometimes we get lucky and they're right, but without actual data and information underlying what the policies are based on, we're going to be patting ourselves on the back for solving problems without solving anything. Some assumptions are very deeply rooted in the space and they're not questioned. And I think we have to start asking even more questions, which then feels more complicated, but I think it gets us to the place where we can actually find the high leverage points and come up with true solutions to these problems so the doors don't get closed at the facility. That's it.
That's great.
All right, well, I was going to go on the regulator side of things on this one, or at least make my statement in direction to that. But Paul's read statement about it, having some challenges with clients. Well, that is a common thread where clients are disappointed if they don't pass the testing. Well, one of the things I like to say is that I would like to encourage clients to do their research and on the front end if they can, choose the materials that they use wisely, research those. Don't build a product and then test it to see if it composts. You should have designed it from the front end with the goal of being compostable. That's an important thing. But then some people have done that, and then in the end they don't pass testing and they're really frustrated with it. Well, the one thing I'd like to say to them then is like, well, if you didn't pass in the lab, well, in the real world, you're really, you're very likely to have similar, because they want, like, hey, is there anything, can you redo the testing, that sort of thing. But in the real world, the product's also going to have problems, and you don't want to put something out to market with a claim and then have it not perform. So that's one message I like to send. But to the regulators, the legislation, I'd like to really encourage anybody that's trying to put legislation in place to firmly understand the rules of testing. I think in lots of cases, I don't mean to insult anybody, but I feel like some of the things I've seen written down in state law, I'm real skeptical that they actually understood, the difference between disintegration and biodegradation testing, and the impact of the choice of words in law are significant. So where a product that really can meet the existing ASTM criteria may fall dramatically short of some state laws, and I don't think that really probably should have been the intention. So anyway, I don't want to, but that's something to spark future conversations, I guess. So.
Thanks, Mike. I'm going to read Paul's answer. He says, in my view, the test methods and standards comprise a pretty good system that has evolved over the last 20 years. Methods are reviewed and debated by committees and are quite transparent. I guess one of the challenges is the transferability of lab methods to the industrial world, and efforts to devise and deploy field test methods are worthwhile and should result in even greater confidence in the management of materials by composting. And now we'll go to Kelvin.
Thank you. And I'll agree with what everybody said. I think a lot of us know exactly who Mike is talking about when you're talking about regulators. But what we need is, we need, to some extent, a national regulation rather than piecemeal for Washington, Oregon, the New England states, California, Minnesota, etc. It would make it much easier for everyone to know what they're certifying to, and that everybody knows exactly what the statement makes. To have a different statement for California, or a different statement for Vermont, or a different statement for wherever, really doesn't help any of us, and it really makes it complicated when you're trying to label and package products. The other thing I will encourage is everyone to participate in helping to set some of these standards. D2096, D34, D10, all have parts of standards associated with industrial composting. And also we're working on backyard, what we're calling outdoor residential composting now. But I encourage everybody to participate, to be part of the process, to make your input and so on, because we're all part of that system for making sure that what we put in place makes sense and works for everyone. D2096 is the largest subcommittee of D20 plastics. It's only in the plastics committee because of default from the paper industry. But we could use with a lot more voices, and a lot more active voices, which I think is very important, because we all have a part of that. And, I want to thank everyone for being here today to listen to all this, because it is very important for us to understand what's going on.
And Kelvin, you mentioned get involved. If you can put into the chat how somebody might do that, if they were interested, that'd be great.
Sure. Okay.
Okay, and then we'll go over to Fred.
Okay. Yeah, I guess one thing sometimes there's challenges with stakeholders that want you to test the material is I really think they need to look more broadly at the whole organic recycling process and how waste is treated in our communities, to understand if that material will be able to be used in a larger context. And so I agree, like, we need national standards. We need to know other materials that may be amongst the ones that they're developing that may restrict just the recycling of that material to begin with, that organic fraction to begin with. So I think this whole circular mindset is important, that we develop a circularity to our waste management processes across the board. I mean, I can just give just an example. This doesn't not totally specific to this case, but our cafeteria here on campus has all compostable, disposable materials that they use, and they end at that thought about where does that material go when it's disposed of. It goes to the landfill. So there's not really much activity in trying to develop, let's get to a composting facility with this material. They kind of end at their edge of their system. So helping to develop more composting infrastructure around the country that can accept materials like this is important. And also, I think another thing is addressing, is there a way to not use the disposable option, and perhaps look in the past at how did we treat these materials before we used disposables, and can recreate systems that don't require these to be used in the first place. And I'm just thinking of our, school cafeterias that are switching totally to disposable materials. And they have dishwashers and ceramics and glasses and metal cutlery available already. And yet they're still doing these transitions to generating 30 bags of trash at every meal, and firing people who wash dishes, essentially. So that may only be happening in our community, but I think it's important to push back against those changes too.
Great. Thank you. Thank you so much, Fred. Yeah, we're coming to the end of our discovery workshop. We've just put a couple of things in the chat for you. If you are interested in coming to the event in September, please fill out this interest form. It's a // wait list. We really want to get a sense of who has been coming to these workshops and is interested in being a part of this conversation, because that's what the whole event is about, is coming up with kind of focused areas for a strategic plan to drive some of this work together, work forward together across boundaries. So like, it's very timely. There's a lot of momentum that we've been generating through these conversations, and we're really excited to see where it leads. Any last comments from you, Candy?
I guess just a reminder that our next discovery workshop number 10 is focused on the professional associations within the industry. And so that's going to be on August 1st from noon to 1:30 Eastern time. And so you can join, great. If you can't, we have all of the previous sessions posted on the project's YouTube channel, as well as this one and all of the rest. And so you will see this video available later today, and just so appreciative of all the panelists, the knowledge and experience that you bring, everything that you've shared to bring your insights into this conversation, and just grateful to all of you and grateful to the audience and everybody following along. This is a whole system strategic planning process, and it takes all of us in order to understand what the reality is and how to move forward because of that. And so looking forward to the conversation continuing, looking forward to seeing all of you again. Thank you so much.